Okay. So how do we start? Ryan.
I would consider the boundary condition first.
What will you consider?
The boundary condition.
It's always a good idea. And remember, what's the main boundary condition in the world? So what do you say?
If first equal to last,
Well, do you need to say that like if? Is if really the thing you want to say?
we can change that into while not. So, but but logically, if they are already, if they are the same, then we are done.
Yes, but you see, it's, there is this thing. Eventually, you will have to have a loop, right? And this loop is going to go. How is the loop going to go? While first not equal to last. So why don't you just say that?
Okay.
So while first not equal to last, do something.
Yeah, get the body block
And
there.
if, by the way, and otherwise, what do you do?
At the end,
Yeah.
we'll return the carry.
Yeah, guys, we're almost done. Right? So
Now come to the hard part.
it's not really hard. So we know that we could look at the first. And we'll look at the first, and what do we ask?
We want to compare to the 0.
I think it's a perfectly fine idea. So let's compare it. How would we compare it? I would recommend that now you had this very important keyword which you tried to use before.
The keyword is
If. If. I think you might try to use it now.
okay. If carry is 0,
No,
carry equals
it
0.
wasn't the question. We don't care what carry is now. Let's assume, by the way, let us just write a precondition. Let's assume that nobody's going to put zeros into our thing. Right? So just write a precondition that in the beginning carry is not equal 0. Just so that nobody will stick zeros in there. If
Then if the
we are pointing here, what do we need to say? Let him say it.
okay, if the star first,
I think that's what we want to say.
if the star first, what do we do?
What do you want to know about first?
Yeah.
Is it 0 or not? How would you write it? You write it exactly the way it sounds, you know.
Yeah, star first equal 0.
So if it's equal 0, then what do we need to do?
Then we push the
Tell us, we are obedient, you're obedient servants. We will do whatever you say. So what's the plan? How does it sound in English?
we'll insert the carry into the first position.
Yeah. How do you do it? How do you, first is a pointer, it points there. How do you store things where pointer points?
Star first equal carry.
I think it might just work.
Or assuming it has assignment operators.
We better assume that it has assignment operator, yes. And no, not otherwise. No, and what? Do you want to continue the loop?
No, this should be the end.
Yes, and we return what?
In this case, return 0.
He even typed return 0. Right? So it's very simple, guys. It's really very simple. Now, what do we do?
We need to use the operators
We need to use op to do what?
to do the reduction.
Yes? Yes, and there is a tricky thing here. So what's the tricky thing? Let us write it and see how he writes it. What do we want to change? No, no. We don't. Well, we're going to carry the result.
Yeah. So carry should equal to
Yes, carry should equal to. I agree with that. Op, I agree with that.
start first. No, I think carry start first. Carry and the comma start first.
Let us argue. Does it matter? Yes, it does, because this operation is not what? Commutative. So this matters somehow. So which one comes first?
I vote carry come first.
Okay, but it's not a democracy, you know. So I vote no. Why do I vote no? And my vote is the only one which counts in this class, actually. You know, I was authorized by management to pontificate, so I can. So why do I say that it has to be like that? Let us understand. Am I just, you know, trying to be dictatorial? That's what Anil will say. Alex wants to be dictatorial. Yes. Who got there first? I actually claim the guys who are pointed by the first got into there first. They are to the left. Therefore, they have to be to the left. It's very important. Right? Do you agree with me now?
Yeah.
Right? Because we somehow they got in there, and they got there before. Therefore, they were to the left of carry. Right? And we need one more line, I think.
So once we have carry
What else could we do? I mean,
in plus plus first.
yes, I think we need to do that. Right?
Okay, so this way we go back to the thing.
And then we need to, before, yes, thank you. Thank you. I'm getting to the, yes. Because we need to assure that whatever was not 0 becomes 0. Thank you. I'm asleep.
Start first equal 0.
Yes. We need to 0 the bit. Yes? This is, believe it or not, extremely wonderful code because it could do all kind of things. Right? But in order to see, even to do a very simple test, let us, okay, Ranping could get out of the torture. That's how it goes, you know. So the correct thing is you never want to sit behind the guy with the spoon. Except you don't know who is the guy with the spoon. At lunch you change, yes. Run away. Yes?
Explain why we're zeroing first.
Why we're zeroing before we're incrementing? Because after we increment, it's too late. Why we're putting 0? Because you see what we do, it's really, do you know how binary numbers work? You know. So if you imagine that you're adding 1, when you add 1 to corresponding position, what happens? If there is 0 in that position, you stick 1 in there. Yes? That's this case. If, however, there is 1 in this position, what do? You combine them, you 0 this position, and you move. It's carry propagate.
Just remind people, this is the counter. There's probably some other range somewhere else with values that we're eventually applying this to, but
That's nothing to do with the counter.
so we're not zeroing the input to the min, we're just zeroing an element of the counter.
Right, whatever it might be.
I don't know if that helps, but
Yes. So now, yes.
For the general add to counter algorithm, it makes sense. But do we need to zero it out if you want to just find second base?
Of course, because otherwise you're not going to balance the tree. It's going to be non-zero. You have to remove the guy who is there, make it 0, and move along. Because you're going to put 1 more and 1 more and 1 more. Guys, you want to keep these bits as clean and nice as possible. Otherwise, it will be total mess and wrong results. You're going through it time and time and time again. You're putting n things, the n things, and log n elements. Remember that. So you're going through these positions many, many, many times. So it's not going to happen once. It's going, I mean, like this guy, the guy in the first position, is going to go 0, 1, 0, 0, 1, 0, 1. You're going to, change its, its value literally n times. Okay? Observe that we're not fully done because we reduced our problem to actually not necessarily one solution. Right? Because when we start putting in things, at the end we stop. And we have how many partial results? At worst case, log n results. Or on the average, half of log n. So we need another algorithm. Like we have an algorithm for adding things to the counter. We need another very high level algorithm of, sort of we take things one by one and then we stop. The things are exhausted. We need to do what? Let's come up with a name. We need to reduce the counter. We need to take these sub-problems, sub-trees, sub-things, and reduce them together. How should we reduce them? Left to right. Why?
for the same, the ones who are lower are, right to left.
I see.
The ones that arrived early are going to be higher up.
Yes. But we don't want to do right to left. Let us think why not. I mean, for this particular algorithm, it might not matter. But let's assume we're doing merge sort. Then we do not want to combine big guys first. We want to combine small guy first. But of course, you're right. We have to. Very good. Very good. See, you were supposed to be answering that. But no. Okay, let us try to write it. Let's try. Yes? Reduce counter. Yes. Okay, but it's probably, you learned by now that no reasonable function is going to be just a function. It's going to be a template, right? At least if Alex is teaching the class. So what do you need to have? Let me suggest a very simple thing. Since it's a dual function to the previous function, you could probably just carry this stuff, right? It's the same arguments. Make sense? Same requirements. Let's be creative. Let's steal. Plagiarize. But always call it research. That's a quote. I didn't make it up. What? Tom Lehrer, yes. Lobachevsky.
Can I just say something else? If you go down, is that the example? Going down?
No. That was he explaining something. Never mind that. Yes. So reduce counter. Yes. What should it return? Yes, but what kind of a type that will be? T, yes? So you have to say loud. T. And what kind of tea? Green tea? Okay. So, and then what does it take? It's a dual function.
First, last.
First and last, he says. Yeah, you never need. It's always first and last. I've been programming 40 years. It's always first, last. Never changes. And then, what do you think after first and last? What else do you need to pass? Operation, yeah, I would say. Do you need to pass an operation which you combine the things? Yeah? Otherwise, you wouldn't know how to add them together. And finally, what do you need? No, we don't know carry. Zero. We need to know what zero is. We need to, again, don't forget, it's sort of reverse thing. Yeah? Okay. You want to try writing it? Here again, sort of, it's a very good idea and it will work, so let's keep it. But, you have to get ready. You're going to be adding things into something. Right? So before you go into the loop, you have to initialize this something. But it's difficult. Here it's a little tricky, guys. Because let me tell you why it is. Let us write it badly, and then we will maybe fix it. The problem here, of course, is that our zero could be a funny zero. Sometimes it is a good zero, like real zero, which is if you take the zero and you take something and combine them together, you get the other something, this other argument. But, you know, often we're going to cheat. We're not going to have this operation being able to operate on zero. Zero is just going to be a marker of empty stuff. Right? So we cannot really initialize the thing till we find the first non-zero. Yes, you do too, yes. Because it might be a funny zero in the sense you might not be able to do op 0x. For example, you know, we might just use in our algorithm an iterator past the end. We don't want to direct, you know, this one. So we want to be here some, you know, you have to think about it. I think you have to pass the spoon. You are really dying. Pass the spoon, pass the spoon. Anil, you have to go. No, or somebody. You just, yes. Oh, yeah? Okay. Okay. All right. Any ideas? Okay, but what are we trying to do logically? Could somebody say it in English? I always, you know, recommend, and this is not just my recommendation, Dijkstra used to say that nobody could write good programs unless he could express himself well in English. He was very proud, especially since he was Dutch, on his masterful command of English. Yes. We discussed that and agreed that maybe it's good to start from the left subtrees because they're smaller. You see, there might be the following property. For very many operations, it is true that adding small subtrees is cheaper than adding big. The right-hand side are much bigger.
I'm not talking about the right-hand side of the counter. I'm talking about the tree under that we were looking at. Because the reducing is that not.
Yes. In the tree, these are going to be right-hand. Yes, you're right. But how would you? I mean, he wants a spoon. You volunteered. I know. And Daniel is apparently very happy to give it away.
I'm thinking we should start at the right side and look for the first non-zero.
I think it's a wonderful idea. So we cannot initialize our result till we find the first not zero. No, we should never have Boolean. There are Booleans. Why do we need a Boolean?
But that means we're carrying state around, though.
No. I mean, I don't understand why.
So you traverse till it's not zero. When it's zero, you initialize your.
No, but you see, there is a wonderful way of knowing that you don't find something. What's the way? To use Boolean or something else? And how do you know that you didn't find it? last, if you get to last, it means you didn't find. That's the beauty of past the end. It means you didn't find. Try. You want to find first non-zero. Find first non-zero.
So I set a variable equal to first, and I keep on testing to 0 as I increment first until.
You know, I mean, actually, I suggest you don't really need a separate variable. Because as you're skipping zeros, do you ever need to look at this part of the range again?
Okay. So while first is not equal to 0.
I still think you want to guard. You cannot check if first is equal to 0 till you checked that first is not equal to last. That's a guard. Because if first is equal to last, somebody is ringing. Is it me?
So inside that loop, so
No, it wasn't me.
while first is not equal to last, if
I would actually just keep writing something in this condition. And
first not equal to 0. Yeah, star first.
very good, very good. And what are you going to do in the body of the loop? It's a mighty powerful body, guys.
First plus plus.
Plus plus first. Let's do it properly. And first, no. Of course, it's incorrect. What are we looking for? For the first guy? Yes. Very good. So now we skipped all the zeros in the beginning. So what do we need to say? No, you're supposed to say that. There are two cases right now. What are the two possibilities? Result of this loop.
First is equal to last, or first is non-zero.
And if it's equal to last, what do we do?
Then we can return last.
We're not returning iterators.
Sorry, return is what last is pointing at.
Yes? No, last is not pointing. Last is pointing. There is a deep, infinite chasm, darkness there. You will start the Third World War if you dereference it. Never dereference last. What should we return if we know,
Oh, yeah, it's not a 0.
zero. No, you have to check something. If, well, I think you said it. When do you return 0? How do you know to return 0?
Oh, first is equal to last.
There could be some clever guy say, well, but couldn't we just, when this is taken, return? Yes, we can, but let's worry about it some other time. Like that. And what could we do now? We know that first is pointing to first non-zero thing, yes? So we should grab it. Be greedy. Put it someplace. How would you do it? Okay, enough of torture. Give it to someone. Yeah, he's anxious. Let him do it.
T-sum equals star first.
I would call it result as a more generalized sum. Very good.
while first not equal last.
I wouldn't do it.
While, sorry,
You already looked at first.
oh, plus plus.
Leave it behind. Ah, yeah.
Or you can do it in the while condition, but we don't want to.
Whatever, yes. Okay,
Result equal op.
no. No, just no. Just no.
If start first is 0 and skip over. So if start first not equal 0,
Very good.
then we do result equals op of result.
And here we have to be very careful, guys. Which way should it be? Who comes first?
Oh, okay. So the guys who ended up higher up, they came first.
The guys who come. So who comes
So the
result or star first?
so the star first. No. So the yes, the star first in this case came first.
Yes.
So result.
Further in the register you are, further in this thing you are, earlier you came.
So op of star first, comma result. Outside of the while, return result.
It's going to run for a while.
No, it has plus plus.
Oh, there is plus plus. It's not going to run for a while. Yes. Very good. Okay, guys, we're reaching the end of our torture session. But you don't really see how it all works. So let me suggest something very simple. We will put this code, and you have to try the following things. For those of you who are really shy and don't want to do much, you want to use this code to add together an array of doubles. Just see how you would use it and whether it works. Okay? For those of you who are more adventuresome, you could try to go further and on your own try to find minimum element. I didn't say min and second min. I said just min. Right? I suspect that most of you could do it within 5 to 10 minutes. It does not require much work. Right? So basically, we will rewrite our min element right now is just doing rightmost reduction. It will start doing the balanced reduction, but you could then check whether the old min element and this min element return the same results. If they don't, then something is wrong, right? They probably should return the same results because we're just reassociating. And then we will continue the next class, which we'll have a different intelligent computer next time around, probably even better. We shall see, we'll have competition. And we will see how there is much more stuff we need to build. All right? Okay. See you in a week.